Hi everyone, Sahil from QuickNode here, and today let's talk about Uniswap. In this video, we will cover what is Uniswap, how Uniswap works, and how the swaps works on Uniswap, and then we will see how we can track these swaps which are taking place on Uniswap. So Uniswap is a decentralized exchange which eliminates the need of a middleman. In Uniswap, you can perform swaps for ERC20 tokens in a permissionless, decentralized, censorship-free, and secure format. All of this happens with the help of smart contracts and algorithms. To understand how Uniswap works, first we will need to understand liquidity pools. And to understand liquidity pools, we will need to understand Uniswap pairs or token pairs. Token pairs are nothing but a pair of tokens, and this pair is of Ethereum and some other ERC20 token. So because the native Ethereum token Ether or ETH is not a ERC20 token, it was implemented before the ERC20 token implementation came in. So that's why a different token called wrapped Ether is used. Wrapped Ether is a ERC20 token and is always pegged to the value of Ether or ETH. Liquidity pools are nothing but smart contracts which manages or governs the rules of withdrawal and deposit of these pairs. The rule is constant product formula, which states that if either of the token needs to be withdrawn from the pool, the other token of the pair needs to be deposited in the pool at the same time. So the constant is always maintained. Anyone can become a liquidity provider for these liquidity pools. They need to deposit both the tokens of the pair for that particular liquidity pool in equal value, and in return they get a liquidity token or liquidity tokens as a proof of their deposit in the liquidity pool. So whenever a trader or user makes a trade or a swap, they need to pay 0.30% of fees to the liquidity pool, and then this fees is divided equally between the liquidity providers of that pool. So whenever a liquidity provider wants to withdraw their funds or wants to withdraw the fees, they will have to burn the liquidity tokens. And now let's understand how the swaps work on Uniswap. So to swap a token with another token, the pools of both the tokens needs to be accessed. Let's say that you have USDC stablecoin token and you want to swap it with DAI stablecoin. So you go to Uniswap and then you start the swap. So what will happen is the pool of wrapped Ether, WETH, and USDC will be accessed. Your USDC will be converted to wrapped Ether, and then that wrapped Ether will be deposited into the wrapped Ether DAI pool, and you will get DAI in return. You won't see all of this happening when you are using the platform, but all of this happens on chain with smart contracts. Now, whenever these swaps take place, a swap event is emitted by that liquidity pool smart contract. That's what we want to track. We want to track for the swap event. So that's what we will do. We will track the swap event with the help of the liquidity pool smart contract's address and the swap event. So let's see how we can track these swap events with the help of QuickAlerts.
We will create this React app in which when you paste the contract address of a Uniswap v3 pool and click on go, it will deploy a notification or a quick alert to listen for Uniswap v3 swaps of that particular token pool. So once there is a swap event, it will print down the transaction hash of that swap event with a link to Etherscan. Something like this. If you click on this link, it will take you to the Etherscan page of that transaction. First of all, to track down the swaps of a particular token, we would need to get the contract address of the pool of that token. So you can get that by going to geckoterminal.com/eth/pools. Over there, you will find a list of various Uniswap pools. And of course, those pools are with wrapped Ether, as we learned earlier that all the Uniswap pools are with wrapped Ether, since the native Ethereum token or the Ether token is not a ERC20 token, and wrapped Ether is a ERC20 equivalent of that token. So let's say that we want to track USDC swaps. So what we will do is we will locate the wrapped Ether USDC pool, and then we will see how that contract looks like, how the swap event looks like of that contract. So we will go to events and we will find out a swap event. So over here, we have a swap event. So this is how a swap event looks like. And we will track these swap events for a particular pool, which is this USDC wrapped Ether pool, by using the contract address, which is this, and then using the topic 0 of the swap event, which is the encoded or the hex encoded or the hash format of this entire swap event. So if you want to learn more about QuickAlerts and how these topics in the log array of an event works and what they represent, check out the video in the description, or you can also check out the video in the info card above. So let's get started. What we will do is we will create a React app, and the main file, which is the app.js of that React file, will look like this. We have also installed Tailwind CSS, and you just need to add these source files in your Tailwind CSS config file. And then we are using a UI library called Sira UI. So you just have to install that by doing npm I Sira UI and add it as a plugin in your Tailwind config file. I will link this in the description below so that you can get this config file and copy paste in your Tailwind config file. So before diving deep into this code and what are all of these different files all about, let's first set up a server for a webhook. So QuickAlerts work with webhooks. Whenever a notification is received, QuickAlerts will send the data on the webhook, and then we will be fetching the data into our front end using a inbuilt different Express webhook. So what we will be doing over here is create a Express server and read from a webhook using that Express server, and then push that data from the Express server to the front end, which is our React app. So to do that, we will need a library called ngrok or ngrok. And what ngrok does is it creates a live webhook URL, which can be used anywhere. So what we will do is ngrok http 4001. So what it'll do is it'll start a server on 4001 port. And this is our ngrok WebSocket URL. So over here, we have a Express server file, and we are importing a bunch of stuff like Express, body parser in CORS, Express obviously to use the Express library, body parser to parse the JSON which we receive from QuickAlerts into a readable format, and then CORS to handle the CORS policy of browser. And then we are starting our Express app and then mentioning the port number to be 4001. And then we are mentioning that the app will use the CORS policy and body parser. We are creating a webhook data variable, which is a null variable. And then we are creating an endpoint to receive the data from webhook. And then we are also creating a webhook endpoint to push the data into our front-end React app. And then we are placing console.log statements everywhere so that it prints the status of that particular Express server. And then we are making our app listen on that particular port on which our ngrok server or ngrok webhook is running, which is 4001. So let's first start this. All right, so now our Express server is running. So let's move to our code. First of all, we will move to destination.js file, where we will set up our destination or webhook destination for our QuickAlerts. And over here, we will need a QuickAlert API key, which we can get from the QuickAlerts dashboard. So you just have to go to QuickAlerts dashboard, click on the API keys section, and then copy the API key from here. Let's go back, replace it with the API key over here, save it, and then let's start the destination.js code. So over here, we have a async function, which is called fetch destination ID. And then we are mentioning few headers which we will require to set up our destination. We are mentioning that the content type which we will be working with is JSON, and then passing the API key as a header. And then we are passing the request with few parameters, which is the request type, which will be post, and the headers, we are supplying the headers, and then we are passing the request body. So the name of our destination will be swap destination. The URL will be the URL which we got from ngrok. So let's copy the URL and place it here. Save the file. All right. This will be our webhook URL on which the QuickAlerts will send the notification or alert with some data. Webhook type again will be post, service webhook, and payload type will be 5. Payload type is the type of payload which we want to receive, as the name suggests. So there are different types of payloads which you can set up for your QuickAlerts destination. The first is block. You can get the entire block where the match transaction is found. You can get all the transactions of that block where the match transaction is found, all the receipts, just the match transactions, just the match transaction receipts, and match transaction hashes with receipts. What we are doing over here is just getting the match transaction receipts. So that's why we are using the payload type 5. And then we are sending a fetch request to the QuickAlerts destination endpoint, which is this, with the request option, which we declared over here. And then we are awaiting for the response. It will be in JSON format. And then we are fetching the destination ID of the response for this particular method. And then we are returning the destination ID. And then we are exporting the entire fetch destination ID function, which we will be requiring in the next file, which is notification.js. So let's copy the API key and set it in the notification.js file. So in notification.js file, we are importing the destination.js file because we will be needing the destination ID to set up our notification. So what we are doing over here is creating a function called send notification and passing the address which we receive from the user as a parameter or argument. And then we are writing a QuickAlerts expression over here and converting into base 64 using this function. And the expression says that track all the transactions for transaction log address this, which we get from the user, which will be the contract address for the Uniswap v3 pool. And then we are tracking the swap event for token swaps, and we are using the topic 0 of that swap event, which is the hash encoded form of that event. And then we are getting the destination ID and then passing the headers again. Request option, we are again mentioning the request to be post, and then passing the few parameters like name, expression, network, and the destination ID. These are the things we need to set up a notification. So this will be our QuickAlerts or notifications name. We are passing the encoded expression, which we set up over here. We are mentioning the network on which we want to set up our notification or QuickAlert on. And then we are also passing the destination ID, which will be our webhook, which we set up in this file, destination.js. And then we are sending the fetch request to the QuickAlerts notification endpoint, along with the request options, which we set over here. And then we are exporting the send notification function. So once the notification is set up using the notification.js file, using the destination, which we created in the destination.js file, we will also need to delete it once we do not need it. So let's quickly get the API key and add it in this file as well. So over here, we are creating a new function, delete notification, and passing the notification response, which we get from notification.js as an argument. We will discuss about notification response variable or payload in the app.js file. So what we are doing over here again is passing the headers, and then in request option, this time the type of method will be delete because we are deleting the notification from QuickAlerts. So we are using the same notification endpoint of QuickAlerts and then passing the notification response, which will be the notification ID as the path parameter for that QuickAlerts notification endpoint. And then we are just returning the response and then exporting the delete notification function. So let's come to app.js, which is our main React file. In this, we are first importing use effect and use state functions of React, which will be used to handle the changing data in our app. And then we are importing notification.js and delete notification.js files. And now over here, we are starting our React app. So over here, we have created some use state variables. First one is address, to handle the address which we get from the user. Second one is to handle the webhook data which we receive from the Express server. And then this is notification response which we get from the notification.js file. Is sending, loading is to handle the loading statuses to turn on and off different buttons or different elements of the app. Then we have two functions over here which are handle submit and handle stop. We'll discuss about this, but first let's understand how our app structure looks like. This is how our app's HTML or JSX looks like. So what we are doing over here is first creating divs, and in one div we are creating a form, and that form will have on submit function, and in that we are using handle submit. So that will be fired or triggered when this button, which is of type submit, will be clicked. So we have two buttons. The first one is called stop. We have an input field. We have a button, which is a submit button. It's called go. We will use the input field to get the address of the Uniswap pool from a user. And then we will set the address in the address variable, which we saw over here. And then we will create the notification using that address, which we saw in the notification.js file over here. So then we are just declaring a link, which will be linked to the QuickAlerts dashboard for that particular notification. And over here, we are handling the transaction hashes or printing the transaction hashes along with Etherscan link. So let's see how that is working. So we are fetching the data from the Express webhook using this fetch webhook data function. And as you can see, we are listening or fetching the data from /webhook data endpoint, which we created in our Express file over here, this endpoint. And then we are getting the data, storing it in the data variable. Then we are creating a new variable, new transaction hash, and getting the transaction hash from the data which we received from the webhook. Because the swap transaction has various internal transactions, we will check the array which we created over here for webhook data. We will check that array if it has the transaction hash or not. If it's already present, it won't print it. If it's not, it will print it. So let's understand about these two functions, handle submit and handle stop. So once handle submit is clicked, which is the go button, which we saw over here, the go button, if that is clicked, the set loading will be set to true. And then we will call the send notification function, which is the function of notification.js, by passing the address as a parameter. So our notification will be deployed, and then the data which we get after the execution of send notification function, we will log that down in response ID variable, and we will specifically log the notification ID of the data which we receive from the send notification function. So the set notification response will set the response ID to notification response. So that's what we saw over here. In delete notification.js file, we were using notification response as a parameter for delete notification function, and also passing that in path parameter for our delete notification function. So then we just have a catch function to catch any error if there's any. And in handle stop, what we are doing over here is we are checking if the notification has already sent the response or not, which means that if the notification is already set or not. And if it's set, we are calling the delete notification function, which is of delete notification.js file, which will delete the set notification using the notification ID. Then we are setting the set loading and set sending as false. Set sending is true until the notification is deployed and we get the notification ID in response. So we are also setting it as false. And yeah, that's how our app looks like. All of these files will be linked in the description below in the form of GitHub gists. So let's try to run our file now. And again, start. All right, so this is how our file looks like. This is the go button, which when clicked, it will fire the handle submit function. This is the stop button, which when clicked, it will fire the handle stop function. So let's get the contract address for wrapped ether USDC pool and set a notification whenever a swap occurs for USDC. So now the notifications should be set. We also get a link to the QuickAlerts dash, which we set up over here in the code. So this link will basically take us to the notification which we set up in the QuickAlerts dash. So if we click on this link, it will open the QuickAlerts dashboard and show us the notification in the QuickAlerts dashboard. As you can see, our notification's name was Uniswap v3 swaps. It was set up on Ethereum mainnet. This was our expression which we used over here. And then this was the address of the pool which we used to set up the notification. And these are the transactions which matches the swap for USDC tokens. So this is what is printing those transactions with the help of this fetch webhook function. And as you can see, we have prefixed the hash with the Etherscan link so that we can click on them and it will open that transaction in Etherscan. So you will see that all of these should be swaps for USDC. So yes, this is a swap for USDC. This is a swap for USDC. Let's try other links. Yes, all of them are swaps for USDC. So this is how you can create a dashboard which will track swaps for a particular token. And now you can see that this notification is there in our QuickAlerts dashboard. It's set up. It's sending the notifications. You can also see the notifications over here. Now let's try to stop it. So once you stop it, the notification will be deleted from your QuickAlerts account as well, or your QuickAlerts dashboard as well, because we are firing the handle stop function, and the handle stop function fires the delete notification function, which deletes the notification. So yeah, this is how you can track Uniswap swaps for a particular token using QuickAlerts. You will find all of these files which we used in the video linked in the description below, along with the Express server file, which is over here. So if you learned anything from this video, give it a thumbs up, subscribe to the QuickNode YouTube channel, and let us know in the comment section what more topics you would like us to cover.